Okay, we're gonna start with binary object features, which is yang part 2 ni. So our discussion ended dekat transformation kan. So sekarang after we have done all the processing and then like after we have segmented the image, so the next thing is what we want to do is we want to extract features. When we say features means we want to extract the features that could describe the object. Kenapa ada bunyi banyak bising-bising ni? Can I mute all of you so that to reduce the ni? Turn off incoming video. How to ni sini. Mute all. All right. So so consider the following segmented image. So ini after segmentation, so all the object will be labeled 1, background non-object 0. So what we want to do is after that we want to use connectivity so that we can separate out different objects. So those that are connected together will be labeled with the same label. Like this is object 1, this object 2, this object 3. So in this case, they use I think apa 6 connectivity, yang mana the direction like this is not considered connected. So therefore you have 1, 2, 3, something like that. So once you have done the so-called object labeling, all right. So in MATLAB nanti you akan observe lah, there's one functions that you call label object. So they will help you to separate out all the object and label them accordingly. So after that, then the next process is to extract features. Of course, there are many features depending on the application. All right, there are 1,000,001 punya features. So, but here are some of the standard one, which is commonly used. So we call them the binary object features like area, center of area. Okay, so maybe you're wondering, so what is all this area, center of area? Kan? So for example, if I want you to tell me, okay, I have examples which is related to your assignment later in your lab. All right, in your assignment, application examples. Okay, candy production. So for this candy production, okay, what I want you to do actually, not you to do lah. So how are we going to differentiate between two type of objects here, A and B? Lambatnya. Yes. So we have two type of object here. Dia tak label dekat sini. Okay. Under additional notes. Okay. Okay, candy productions. Suppose you have a problem like this, where you need to automate your production line. So you have two types of object. Okay, so you want to install a robot arm, because by having robot, then you can you can be more efficient, right, compared to manual. So so what you have two types of object. Object A, object B. So how are you going to be able to first identify where the object is? Okay, identify individual object and also where they are. and then differentiate between A and B, and then itulah. So this is you punya problem lah. So you want to install robot arm and you want to program it. So you have to move according to the coordinate. So you have to propose how to develop the control program. So the problem is, first you have to identify the object. Where? And then, so that you know, and then you can differentiate A and B. Okay. So tadi bila masa kita punya discussion, alright, so segmentation help us to, alright, like in this problem, segmentation is basically using color. So so the background white, anything not white means those are the pixels for object. And then you're going to do some labeling algorithm. Okay, so the labeling will help perform the connectivity. So we'll connect all the similar pixels after segmentation and form them as object. So and then after that, that's where you need to extract the features. Use some of the binary object features here to differentiate between A and B. Now my questions to you. So what is the difference between A and B? Boleh jawab?
Color, sir?
No, A and B. Kalau kata color, kalau merah, A pun ada, B pun ada. Coklat, A pun ada, B pun ada. So it's not color. Color is used to differentiate between object and background. Anyone?
Size?
Exactly, size. Yes, good observation. Siapa cakap tadi?
Saya.
Manalah saya tahu nama you saya.
Yati.
Yati, jangan cakap saya. Okay, right, size. Tapi exactly how do we, macam mana kita nak measure size tu?
Shape.
Shape. Shape pun tak boleh sangat sebab ini dua-dua sama color, sama shape. Ini pun sama color, sama shape. So shape dengan color memang out lah. Tapi size boleh lagi lah sebab dia A dengan B kan. Kalau you observe, dia memang satu besar, satu kecil kan?
Yes.
Yes, sir.
Ada besar, ada kecil. So dia size lah. Yang besar tu A ke B?
A.
A kan? So yang besar A, yang kecil B. Okay, so how are we going to measure size?
Amount pixel.
Amount of pixel, yes, exactly. Good guess. You are the talent lah dekat image processing. Okay, so that is actually the features called area. Okay, so when you calculate the number of pixels that forms an object, that actually is the area. They call it lah, just the name of the features lah. Okay, so this is the binary object feature. So once you have this, then we separate out all the objects so that we have only one object in one image. So this is the binary image for each object. Binary image of each object. So then from there we can start to extract features. So area, the definition of area, very simple. You sum the whole image. So when you sum the whole image, what happened? Ini dia punya area berapa? Kalau you totalkan pixel dekat sini. Yang background semua kosong kan? So dia will not affect the sum. Only those pixels which belongs to the object will affect the sum. So how many pixels are there?
7.
Yes, exactly. So what is the area for this object? 7. And this slightly bigger one, what is the number of pixels here?
8.
8, exactly. So the bigger the object, the bigger the area. So this is the first ever features that you learn. The 8 features which is related to the size of an object. And how do we calculate that? Formal definition is you sum the whole image of the binary object. And when you sum, all the background will not affect the sum, only the pixels which belongs to the object. So practically you're counting the number of pixels of the object. Boleh ikut? Senang saja kan?
Boleh, sir.
Sir.
Okay, good. So itu adalah yang senang sekali, area. Okay, then we also have other binary object features like center of area. Apa center of area? Center of area basically is you calculate the average R and average C. You kira dia punya average location. Boleh ikut formula ni, nampak tak? Dia R, row index dia darab dengan dia punya pixel. So bila dia darab, and then you sum for all the pixels, you take their row index, multiply with their value. So you can see that those that does not belong to the object is 0. So when you multiply 0, basically you get 0 lah. So it will not affect the sum. Only those pixels which belongs to the object, so you will have their value non-zero or 1. So multiply with their row and column. So practically you are summing their row and column index and divide with the total number. A is actually the area. Area means the number of object pixels yang you kira dekat sini. So basically you are calculating the average row and average column. So you are calculating the center of the object. Are you following? Center of area. All right. Any question? So if you calculate the center of area for object ini, then you will get basically the center point here. And for this, you'll get a center point here and so on. Are you following?
Yes, sir.
Okay, the detailed calculation for the rest, like this one, I'll not explain further. All this actually they derive from some physics measures. Okay, like all the center of areas is something that they get the idea from center of, apa? Masih ingat dekat science physics tu ada center of apa? Center of gravity. So benda-benda ni dia basically they derive from there lah. Yang ini basically they try to ini adalah apa? Least second moment axis. Okay, so this is this axis is basically expressed in the angle from your vertical axis. Okay, in a counterclockwise. So it basically tells you the orientation of the image. So basically tell you it's actually towards left ke, towards right ke, or horizontal ke, or vertical ke. All right. Of course, calculation here is not trivial lah. It's quite complicated. But what you need to know at least that you have a features that could express related to the orientation. Okay, it's about orientation. Just like center of area is related to your apa? Center of area related to apa? Size kan? Okay, so this is related to your orientation. Okay, so okay, next you also have what we call a perimeter. Everyone know what perimeter is, right? So basically it tells you the length of your so-called H pixel. So you can see how they actually calculate this. It's done by scanning this pattern. So they try to scan a center pixel which is surrounded by 4, 1 like this. And then they know that this is not a H pixel. This is because it is fully surrounded by 4, 1. So therefore it should not be counted. So what they do is try to scan for this pattern and then they set the center to 0. So like this. So after that, after scanning, this one becomes 0. See, all the center becomes 0. Okay, and then what remains are the pixels which we can include in counting the perimeter. So all these are H pixel. So what is the perimeter for this object? 6. And this one, 1, 2, 3, 4, 5, 6, 7. This one, 6, 1, 2, 3, 4, 5, 6. Everyone, are you following about this perimeter?
Yes, sir.
First, you scan for this pattern, and then you set the center pixel to 0. Why? Because when it is fully surrounded by 4, 1, then it should not be considered as H pixel. And once after you have done the scanning, what remains are all the H pixels, which you can then start counting to know what the perimeter is. So once you have the parameter, then you can use it to calculate a more useful features, which is later related to you punya assignment. Okay, this is called thinness ratio. Thinness ratio is something to do with something closely related to like kita punya body mass index. Do you know what body mass index is? BMI?
Yes, sir.
Everybody, you know what BMI is, right? It's basically an index to apa? It takes our height and also our weight.
Wait.
Yeah, it's basically an indication whether we are overweight or underweight or just nice. Okay. So this one plays the same. Dia punya idea is very much the same lah. It basically takes the area divided by perimeter. So area is basically the weight lah. Perimeter is basically the surrounding pixels lah. Okay. So what happened when you have a very thin object? What happened to this ratio? Can someone guess or analyze this formula? When someone is thin, then in English we also call skinny. You know, skinny. Which one is related to skin? A or P? Anyone?
Is it A?
Skin, skin. Kalau kita kata the skin of the object tu,
The
skin of the object. Yes, the perimeter lah.
Perimeter.
So P lah ni. So bila orang tu dia very skinny, maksudnya dia punya weight, ni dia punya isi lah. Ini area kan. Area dia seumpama isi lah. Ni area dia kan. Kalau kita kira area is the whole object kan. Itu macam weight lah, kita punya weight, kita punya isi. Lepas tu kalau P tu dia hanya kira dia punya the skin, the edge. Okay. So when someone is very skinny, when you say skinny means the skin is small lah. So when this is high means what? The whole value become T is low or high. Bila P ni sangat tinggi, compare to A, apa berlaku dengan T?
Low.
Yes, exactly. So bila the value, the object is thin, macam ni kan, T ni kan dia nampak macam tulang dia kan. So this T looks skinny as compared to a round object like this. You can look at the T. This T is relatively low. Okay, just like our BMI and someone who is thin, the BMI will be low. Someone who is a bit so-called overweight lah kan, obese kan, so dia bulat kan, then dia akan nampak BMI dia akan tinggi lah. So same like here, the T here will be high lah for round object, and then for all those skinny object or the irregular object like this kan. So you can see basically it's not fat, it's basically very thin. So you can see the T is very low. So this is something very much related to your your lab punya assignment nanti. Okay. Kalau you tengok assignment ni, so your job is to differentiate two shapes. One is a round object, one is a thin object like this. So your assignment, 5 marks. Okay, so you have to write a MATLAB program. You extract all these objects, and then after that you have to decide which one is round object, which one is thin object. Itulah kerja you nanti. But don't worry, we'll guide you through. You don't have to write all the codes from scratch. I'll give you a template. Okay. So, but of course now the first thing you have to make sure your MATLAB start running lah. Otherwise, useless lah to talk about all this. Okay. So as I said, this T is closely related also to the regularity of the shapes. Irregular shape like this also tends to have very low T. So sometimes they also use this T, the inverse of T. Okay. they use this as irregularity ratio. When you have regular object like this, like round shape or square or triangle, okay, these are all regular shape that you see in your daily life. So there tends to have a very low irregularity. So, but when you have an irregular shape like this, which looks very odd, weird, so we call it irregular shape, then 1 over t will be very high. So can also use this to measures how regular or irregular a shape is. Okay. And then you also have aspect ratio, another features, which basically tells you the ratio of dimension. So whether it's spread vertical or spread horizontal. So can you tell me if it's spread vertical, dia tegak, ini ratio dia tinggi ke rendah? What happened to the ratio when the object spread vertically? Kalau spread vertically maksudnya dia punya R ni besar kan? Dia punya height R max minus R min should be high kan? So this is high, this is low. So what happened? The aspect ratio will be very
small.
Yes. So when it's spread horizontally, meaning this is high and this is low relatively. So therefore the value should be higher. Okay, this is another features which is important for your test. So Euler number. So Euler number basically helps you to determine the number of holes, something related to holes. So Euler number is number of object minus number of holes lah. So basically like in this image you have 8 object, so 1 hole ni lubang. Okay, so how many object? 1, 2, 3, 4, 5, 6, 7, 8. 8 minus 1, 7. So the Euler number of this image is 7. And the Euler number of 1, okay, is 2. Okay, the letter V here, if you talk about individual object, this V here, basically your Euler number is 1. Okay. Why? Because one object, 0 holes. Everyone, are you following?
Yes, sir.
And kalau I, how many object, how many holes? 2 object, 2
No
object, no hole. So for I, the Euler number is 2. Kalau S, 1 object, no hole, so 1. Kalau O, 1 object, 1 holes. So you can see different alphabets that have different Euler number, except like those that has no hole lah. Like I ni 2, yang ini V dengan S sama. So actually in a very early stage, this become one of the features. Okay, of course they use other features to recognize character. Okay, based on Euler number. And this one, if you look at there are 3 objects, 2 holes. So the Euler number is 3 minus 2 holes, 1. Okay, so the next question is how do we extract these features? Holes, although when you check, you look at it visually, you can detect, but how do you get computer to scan it? So to scan it, we use these convexities and concavities derived from graph theory. So we need convexities. Nampak tak dia? It's like 1 surrounded by 0. It's like object, the beginning of an object. And these concavities, you can see the pattern is very much related to a hole surrounded by what? So this is related to object, this is related to holes. All right, so then Euler number you can approximate with number of convexities minus number of concavities. Okay, so and last but not least, we have the projection. Okay, the projection is useful when you want to describe more shapes. Yang ini simple punya shapes like holes and all this. But if you want to have a more comprehensive description of a shapes, then we use what we call the projection. So you have the horizontal projection and vertical projection. Like for example, a vertical projection for first column 0. So you sum all the object pixels here. And second column is 1, third column is 2, and so on. And then you have the horizontal projection like this, where you try to sum each the object pixel for each row. Like the first one is 1, second one is 2, third is 5, and the 6, and so on. So that all these numbers, which is not one number, but a series of number, or we call it a vector. So this feature vector, okay, will then be used to describe the shape of this. Any questions so far? Okay, if not, then point you to the additional notes where you can look at how I implement it in Excel, all these features, binary object features. Oh, sorry, not additional notes, dekat notes ni. I put it together, binary object features kat sini. Okay, so this is area of this object, 20. So if you count the number of pixels, it's 20. And then the center R and center C is 5.5 and 4.5, 5.5 and 4.5 dekat sini. So basically is the center of the object. And least moment axis is 90 degree, betul lah, dia flat macam ni kan, dia spread horizontally. And the parameter is 20. This is the parameter. If you count 20 pixels, same as your area. And then you calculate the thinness ratio is very low because it's very thin. Okay, and then the R max and C max. So you calculate aspect ratio 2. So basically it's large, so it's spread horizontally. And you can also calculate the compactness. Okay, so if I change this, then you can see the value here change immediately. Kalau saya fill up this, then you can see the thinness ratio should increase. Nampak? The thinness ratio increase to 1. If I remove, reduce to, sorry. If I reduce, becomes 0.6. Okay. So this is where you can experience with the object holes. So in this case, the Euler number of how many objects are there? One object and 2 holes. So 1 object, 2 holes, -1. So if you look for convexities and concavities, basically 2 convexities. Do you see 2 convexities here? 1 and 2. So 2 convexities and 2 concavities, the one that is related to holes, and also the one which is here. So 2 minus 3, -1. Are you following? Calculate Euler numbers. Okay, I think with all this, then maybe you need to have some practice. Other sample questions. So for all the future revision, you refer to the sample questions lah. Sample question. You know where to get the sample question, right? I already emailed you the link.
Yes, sir.
Yes, sir.
Okay. So we are now under features extraction, page 22. Yang ini next week punya, Next week punya test lah, ni untuk the one that we have discussed last week. This one also histogram, which we're going to discuss next week. Okay, so yeah, you will have question like this is comprehensive problem solving questions lah. So you'll be given object like this, and then you are asked to propose the features that could differentiate between object A and object B. So what features are there that you can use? Kalau you kata area, boleh ke area nak guna? Area object A berapa? What is the area of object A?
11.
Yeah, 11. And then B pun 11. So both are the same. So can you use them to differentiate the two group?
No.
No, because then if you want to use the features, then it must be different across different group. Betul tak?
Yes.
If they're the same, then how do you tell whether it's A or B? So area is definitely out. Orientation boleh ke? Ini pun, if we did the same group, we have horizontal orientation, we have vertical orientation, and same goes with B. So orientation also out. And then is it about location? No, both. All the objects are in the center, so location pun out. So what can we use? So you nampak tak the object here, the two object here, dia nampak macam tulang sikit kan? It's more like thin. And this one is more to a more compact object. So what is the features that's related to thin and compact round object like this? Remember that we have discussed about the features. This one.
Perimeter thinness ratio.
Yes, we use thinness ratio lah. Okay, so you have to suggest lah thinness ratio and why you extract thinness ratio. So basically your answers will be first what features to use. So in this case we propose thinness ratio, and why do you propose that? So the what followed by why, because you observe your visual observation group A is thinner compared to group B, and then you have to explain how. Okay, the first is what, and then followed by why, and then followed by how. So how, then you have to explain your A, what is your P, how to get them. So A is actually total number of pixels that form the object. Okay, so it's the area, and P is defined as a total pixel constitute the H. Okay, and how to extract them. Okay, so to extract this, you can scan the pattern and then turn 0 and benda-benda ni lah. And how do you use the features? So A is thinner compared to B, therefore how is it related to the features? So thinness ratio, features value dia akan lower compared to B. Okay, so you need to explain what, why, how, and also how to use the features, interpret the features, and then you have to verify. You have to calculate the features value. So A object 1 11. What is the P? P also 11, and so on. So you do the calculation for each of the object. A1, A2, B1, B2. Sorry, this is not A. It's B1, B2. So then you get the final result, and then you show yes, since this one is lower compared to this, and then within the same group they are the same, and across different group they are different. Therefore, you can use them to classify, to differentiate the object. So this kind of questions usually will cost you a lot of marks in your final, 15 marks. Usually it will come in your section B, problem solving. Any question?
No, sir.
So next week ada test lah on something like this. I'll give something similar question except the shape might change. And I might also give you shape which is related something like this. Yang with holes. So in this case, it's no longer about your It's nothing to do with thinness ratio, but it's something to do with holes. So what features should we use for holes? Other related to holes? What is the feature's name?
Euler.
Yes, Euler number. Again, you explain what features to use. Why? Okay, so why means since they have this one have one hole, two hole, Euler number to use. Okay, and then also how to calculate them, Euler number, and then define Euler number, and then how to extract features. So you use scanning convexities and concavities, and then you do calculation. Okay, and of course then you have to explain also how to interpret. So small Euler number means what? It should be A or B. But ini more holes kan, so more holes means the Euler number should be smaller lah, because it's object minus hole. So then you verify lah, you do the actual calculation, and then you show that what you actually expect to happen here. Object B should have smaller Euler number, and then you do the verification. Memang smaller. Okay, so that's how the whole answer should be lah. Alright, so that is about ni. Ada apa lagi? Ini kita dah discuss. Okay. It's about holes. Okay. This one we'll discuss later next week. Histogram features. Okay. So any questions so far?
No, sir.
Okay, if no questions, then let's call it a day. I'll see you next week. Boleh?
Boleh, sir.
Okay, so again, I have to do stop recording.